So this is a video that's meant to be a tutorial on how to put pH problems into your calculator. Okay, and I'm going to start with scientific notation because I still see students putting it in longhand. So if you go 2.7 times 10 and then exponent to the negative fourth, that certainly is a viable way so long as you have a proper number sense. But if I say enter, then I get this shorthand notation. This is calculator speak, at least Texas Instrument calculator speak, for 2.7 times 10 to the negative fourth. So then if I just do that, there's a lot fewer keystrokes, and it's the way the calculator is designed to think. So with the TI, I can put it in just as written. Negative log 2.7 times 10 to the negative fourth equals 3.5. We'd round that to 3.57. Now, with a Casio, but this is just representative of a different way of doing it. Sometimes you have to put the numbers in backwards. It's kind of an order of operations thing. So this, you have to put the number in first, 2.7, and then this is the exponent key. So this means times 10 to the negative fourth. Okay. And notice there's no E button, and that looks like 2.7 to the negative fourth power, but it's not. It's 2.7 times 10 to the negative fourth. Then I want to take the negative log of that, but first I have to take the log, and then I have to make it negative. Okay, and you can see I get the same answer. Okay, so some you have to do just as it's written, others you have to work backwards. Okay, and you have to decide which type your calculator is. So if we go to this next problem, we know that the hydronium concentration equals 10 to the negative pH. And some of you on your worksheets would put that as your final answer, which certainly is correct, but it's incorrect in that it's not the proper notation. So you have to solve for it. You have to simplify it. So as is the other case, you put it in directly. So the inverse of log is 10 to the x key. So you hit second button, then the 10 to the x, and then negative 1.2. Okay, and then equals. Now that would be proper. In scientific notation, it's that. Okay, now the Casio, you have to put it in reverse. So you put in 1.2, you make it negative, and then you hit the 10 to the x key. And you get the same answer. And this one, we're using this function where the product of the two ions in water solution is always equal to 1 times 10 to the negative 14th. So if you know this one, you can find that one. If you know that one, you can find that one. So here we're given the hydronium concentration, so we simply take 1 times 10 to the negative 14th and divide it by the hydronium concentration to get the hydroxide concentration. So the question is, how do you put it into your calculator? So you use the scientific notation key. So let's get it into position. So you go 1 times 10 to the negative 14th divided by 5.2 times 10 to the negative fourth equals. Oops, I know what I did wrong. Okay, and I'll pretend like I did it on purpose. If you look up here, and I don't know how to get in there, I hit the subtract sign instead of the negative sign. So if one of you were here to show me, I could get up there and fix it. Otherwise, I'll just go 1 times 10 to the negative 14th divided by 5.2 times 10 to the negative fourth. There we go. 1.9 times 10 to the negative 11th. Oops. So that answer's wrong. Okay. Now, down here, this table is designed to show you that if you know one thing, you can find all the others. So, ask yourself, if I know the pH, how do I find the hydronium? There it is right there. So how do I put 10 to the negative 2.5 in my calculator? 2.5, make it negative, second log. And I get that. With this calculator, I can put it in directly. Second log, let me do that again. Second log negative 2.5. And that's just the standard notation for this in scientific notation. Now, how do I find the pOH? Mental math. This plus this always add up to 14. So I just take 14 minus that to get that. And then if I know this, I can find this. If I know this, I can find this. So I simply take 1 times 10 to the negative 14th and divide it by that to get that. Or I can take the 10 to the negative 11.5 and get the same thing. And then from any one of these, you should be able to tell whether it's an acid or a base. Okay, so I hope that helped. I have a written, typed up tutorial that will also accompany these lab calculations. So good luck with them, and don't hesitate to email me if you have any questions.